Okay, so we move to the concept of hypothesis testing. So in our scientific process, the scientific process, I think, is observation, hypothesis, theory, law, and I am sorry, but I really cannot remember it in its order. But I know that there is a scientific process and hypothesis is part of it. So hypothesis is an assumption the researcher tests to see if it holds true in the research. It is essential in making inferences. Before you start your research work, you must have something at the back of your mind. You must have a problem that you want to prove or disprove. And that's why you are going to collect data. That's why you 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 are running your analysis with statistical software and getting a test statistic to see whether your hypothesis holds true or not. So a research work must have a null hypothesis to which the researcher tests against the significance value set for the research work. So you must set a significance value, like I talked about earlier. The significance value is based, you can, as a researcher, you can set your significance value at 0.05, 0.01, depending on your research and what it covers. So null hypothesis is the assumption the researcher tests statistically. And then the alternate hypothesis is the assumption that holds true when your null hypothesis fails. So if you fail to prove that your null hypothesis stands, your alternate hypothesis takes over. So in a research work, there must be a null hypothesis. There must also be an alternate hypothesis. So let's say you want to determine if the number of hours on social media affect the performance of students in exams. You can see that the null hypothesis here is that the number of hours of social media does not affect the performance of students in exams. And then the alternate hypothesis is that hours spent on social media affect the performance of students in exams. So now you run your analysis, you run your test statistics, and you get a p-value that is lower than your significance value. If we get a p-value lower than significance value, we reject the null hypothesis. And so the alternate hypothesis stands that social media spent affects performance of students. If your p-value is above the significance value, that's your 0.05, that's the maximum level of risk that you are willing to take for that paper. If your p-value is above it, we fail to reject the null hypothesis. Remember, in statistics, we accept. We are working under the framework of probability, chances. So we are still leaving that element of chance in the study. So we don't say we accept the null hypothesis or we accept the alternative hypothesis. Oh my God, happened. Alternative hypothesis. Okay. So if your p-value is greater than 0.05, we fail to reject the null hypothesis. And so since we fail to reject the null hypothesis, our null hypothesis stands. So if your p-value is less than 0.05, we reject the null hypothesis, and so our alternate hypothesis stands. Let me see if I can in the report. Okay, so in this report, we examined age of respondents, association between age of respondents and variables, that's ANC registration, ANC at first trimester, ANC at second trimester. We used a chi-square test to find the association. As you can see, all of them showed a p-value of less than 0.005. Even assisted by friends and relatives showed a p-value of less than 0.005. So while reporting, we established our research hypothesis. We said our null hypothesis signified as H0 says there is no significant association between age of respondents and the level of utilization of health facilities for delivery. And our alternate hypothesis says there is a significant association between age of respondents and the level of utilization of health facilities for delivery. Our significance level for this paper was set at 0.05. So we measure our p-value against that 0.05. As you can see, everything is less than 0.05. That means anything less than 0.05 is significant. Anything less than 0.05 is significant, and anything less than the 0.05, which we have set as our maximum level of risk, we say it is not significant. So since everything here is less than 0.05, we say that all p-values for the statistics are less than significance level chosen for this research study, 0.05. Hence, we reject the null hypothesis and the alternate hypothesis, which states that there is a significant association between age of respondents and level of utilization of health facilities stand. So that is simply it for hypothesis testing. So for hypothesis testing, you have your null hypothesis at hand, you collect your data, you run your t-statistics, and then you compare your t-statistics to the alternate, to the significance level. If it is less than your significance level, if it's such a significance level of 0.05, if it is less than if your test statistics is less than 0.05, you know that your estimate is significant. If your test statistic is 0.05, which is above the level of risk you as a researcher has set, you know that there is no significant association. And so from there, whatever you get, you can use it to make an inference. So that is that for hypothesis testing, and that is all for the statistics video. Thank you for listening, and I encourage you to keep watching the videos over and over and over and over again, and we get the hang of it. Thank you very much.